Okay, part two, sorry I lost you. So we're going to move all the y values down 5, so that would be 2 minus 5, negative 3, 1 minus 5, negative 4, negative 5, negative 4, negative 3. It doesn't matter which one you do first because they're both technically multiplying by a negative and then multiplied by a 2. So what I'm going to do is just, I'll follow the negative first. So I'm going to make all these negative because the reflection across the y affects the x, then multiply them each by a half. So, all right, so that would mean the negative 2 multiplied by a negative and then times a half. So that become 1. Negative 1 times a negative is 1 times a half, 1 half. 0 times a negative times a half, still 0. 1 times the negative, negative 1 times a half, negative a half, and then negative 1. Domain. Range, the negative 2 on the inside affects the x's, so that's not going to affect the range here, but the down 5 will. So I moved it down 5, so negative 5 going towards infinity. All right, next ones are solving. Isolate first. Okay, so that means in this problem you want to divide by 6 first. Absolute value of 4x equals 3. Check, is it equal to a negative? No, it's not, so continue on. We're going to solve 4x equals 3, and then 4x equals negative 3. In both cases, divide by 4. X is equal to 3/4 or negative 3/4. Okay, next one. Isolate first, so what we're going to do is minus 3 minus 3 to absolute value of y minus 7 equals negative 8. Divide by 2, divide by 2. Absolute value of y minus 7 equals negative 4. Isolated, check. Is it equal to negative? It is. So if it's equal to a negative, that's impossible. Okay, do not make this call too early on or too early. Just because you see a negative over here does not necessarily mean there's no solution. You need to isolate first because doing some of these operations to this side can make that negative back to positive. Next one, add 5. 4 times g minus 2 equals 12. Divide by 4. Absolute value of g minus 2 is equal to 3. So it's not equal to negative, so we can solve g minus 2 equal to 3 or g minus 2 equal to negative 3. Add 2 in both cases, so that's 5, or add 2 over here, negative 1. Okay. The next ones have expressions or absolute value on both sides. So the first one you can't really isolate because there's absolute values on both sides. So what we're going to do is just solve x minus 2 equal 4 plus x. Just drop both bars. And then the next one you're going to solve or x minus 2 equal to the negative of 4 plus x. Okay, so we're going to have some distributing going on here on the second one. So what I'm going to do is subtract x from both sides here. And what you'll notice happens is both x's cancel. We get negative 2 equals 4, which is false. So that's an extraneous solution. So nothing's going to happen there. But over on the other side, x minus 2 equals negative 4 minus x. Now we're going to add x, which does not cancel on the left. It'll give us 2x minus 2 equals negative 4. Add the 2 to that other side, negative 2. Divide both sides by 2, and we get negative 1. So that'll be our answer for that one. Here, no isolating. It's already isolated, so we're going to solve 3x minus 4 equal to x, or 3x minus 4 equal to negative x. Okay, so I'm going to subtract x here. 2x minus 4 equals nothing. Add 4 to the other side. 2x equals 4. X equals 2 after you divide. Add x. 4x minus 4 equals 0 again. Add the 4 to the other side. 4x equals 4. Divide by 4. X equals 1. Now something I forgot to mention on the previous one, which I'll mention now, is I would check your answer anytime it's equal to an expression. If it's equal to a constant, I won't worry about it too much, but when it's equal to an expression, definitely check. So some of you can do this in your head, meaning if you plug in a 2, does it work? So is 3 times 2, which is 6 minus 4, is 2, the absolute value of 2, does that equal, if I plug in a 2, 2? Yes, it does. If I plug in a 1, 3 times 1 is 1, minus 4 is negative 1, but the absolute value of negative 1 is 1. Does 1 equal 1? It does. Both of these work. And the previous one, if you check, negative 1 minus 2 is negative 3. Absolute value of 3 is, or negative 3 is 3. 4 plus negative 1 is 3. 3 does equal 3, so negative 1 does work. Next one, there's really no isolating. It's already isolated, so we're just going to solve 4x plus 5 equal to 2x plus 4. 4x plus 5 equal to negative of that, 2x plus 4. Subtract 2x. 2x plus 5 equal to 4. Subtract the 5 over 2x equals negative 1. Divide by 2. X equals negative a half. 4x plus 5 equal to negative 2x minus 4 after you distribute. Add 2x. 6x plus 5 equal to negative 4. Subtract the 5. 6x equals negative 9. Divide by 6. X is equal to negative 3 halves. Check both of these, but if you check both, they should work. But just be very careful to check. Okay, moving on. Now we're into some inequalities. Steps really don't change much. You're going to isolate the absolute value. Once you have it isolated, you're going to solve whatever's on the inside, greater than or equal to 2, whatever's basically just drop the bars, or switch the sign and make negative. Okay, so m is greater than 2. If you think of this on, if you had to get this on a number line, we have negative 2 over here, 2 over here. M is greater than or equal to 2. M is less than or equal to negative 2. They're going away from each other. That is an or statement. Okay, next one, divide by 2. Absolute value of k minus 9 is less than negative 2. Stop. We have a negative after we isolated. Check if it's less than a negative or greater than a negative. We have a unique solution. When can the absolute value be less than a negative? That's not possible. It can't even equal a negative, right? So it can't be less than 1. So no solution there. Here, we just got to divide by 4 to isolate. Absolute value of f minus 6 is less than or equal to 3. After you have it isolated, f minus 6, just drop the bars in the first case, and then f minus 6 is flip the sign, set equal to the negative. Add 6. Add 6. F is greater than or equal to positive 3. On a number line, we have 3 and then 9 over here. F is less than or equal to 9. F is greater than 3. They're going towards each other. So this is an and statement, which I would like for you to write like this. 3 less than or equal to, I guess that's an F, less than or equal to 9. That's how you write your and statements. You don't need to write the word and. You can just write it like that. 14. Isolate. After it's isolated, is equal to a negative or greater than negative? No. So let's solve b plus 8 is greater than 4. B plus 8 is less than negative 4. In both cases, you're going to subtract 8. B is greater than negative 4. B is less than negative 12. We have negative 12 over here. We have negative 4. B is greater than negative 4, so this is going to be an example of going away. So that is an or statement, so you can just say or, and there's your answer. Minus 6, next one. Is it less than or greater than a negative? No, so we continue on. Flip the sign, make negative. Here we have to divide by a negative. Don't forget, any time in math, you divide by a negative. Doesn't matter what, algebra 1, geometry, doesn't matter. You have to flip the sign. That rule will never change. So I flip that sign from less than to greater than, and it's going to happen here as well. G is less than 0. Number line, let me see here. We have 0 and -4/3 is over here somewhere to the left of it. G is less than 0, G is greater than. They're going towards each other, so I can say -4/3 less than G less than 0. That'd be an and statement there. And last one, -10, -10, 9 minus 2j is greater than or equal to -8. I isolated my absolute value. Check, is it greater than a negative? It is greater than a negative. If it's greater than a negative, it's going to be all real numbers. Okay. All right, next type of question is evaluating functions. So we have g of -5. So you're given domain restrictions here, -7 to -1, -1 to 3, and 3 to 10. Find where does -5 land on this? Well, -5 is between -7 and -1, so that means I'm going to plug -5 in for this x. So these other two you can just ignore. So we're going to solve, plug in -5 for the top one. Okay, -5 squared is 25. 3 times 25 is 75, minus 2 is 73. Okay, g of 2. 2 is between -1 and 3, so we're going to plug it into the middle one. So that's just 3 times x, or in this case 3 times 2, which is 6. 6 falls between 3 and 10, so we're going to plug it to the bottom one. That's 2 times 6 plus 1. That's absolute value of 12 plus 1. That's absolute value of 13, which is just 13. And the last one, -2. -2 is between -7 and -1. So we're going to plug it in the top one. So that would be 3 times parentheses -2 squared minus 2. That's 3 times +4 minus 2. That's 12 minus 2, which is 10. Okay, moving on. Last topic. Graphing. We have a constant 5 when anytime x is less than 0. Okay, so anytime x is less than 0, we're going to have a constant at 5. So constant at 5 is a horizontal line, but I only want it when x is less than 0. I'm going to put an arrow because it says x is less than, which means it continues on. Okay, the next one, 3x. That's a line, so it's a slope of 3 and a y-intercept of 0. But I only want that between 0 and 3, so I have to go in this range here. So what I'm going to do is y-intercept of 0, slope of 3, up 3 over 1, up 3 over 1. And once I get to an x value of 3, I'm going to stop, which would be right there. And then the last one, x plus 2 is another line, y-intercept of 2, slope of 1, up 1 to the right 1, up 1 to the right 1. Now here I just like to make just a tiny dot so I can kind of see where I'm going, because I only want that to go x is greater than 3, which is starting right here, going in that direction. All right, so is this discontinuous or continuous? This is discontinuous because you can't draw this without picking up your pen. Domain, well, how far left and how far right? Actually, this goes left forever, and there is no gaps in here, so it should go right because of the arrow, right forever. That's one way to tell graphically. If you look up here, with x is less than 0, and then 0 to 3, and then x is greater than 3, that covers every possible number from -infinity to infinity. So you can tell by the domain restrictions here. The range, looks like the furthest down it goes is 0, and I'm going to include that. And the furthest up, because of the arrow, looks like infinity, and there is no gaps in the range. Okay, the next one, we have another constant at -3, but between -10 and 0. So that would look like this. 2x minus 3 is a line, y-intercept of -3, slope of 2, but I want to stop when between 0 and 4, so I want to stop when I get to 4. So up to the right one. I'm going to stop right here. I can include and include because filled in. So if you have an include, a filled in circle on top of an open circle, it just fills it in. And the next one, -x plus 9, is another line, y-intercept of 9, slope of -1, so down 1 to the right 1. I'm just kind of making a mental note because I only want x is greater than 4, so I only want to start it here and continue on. And I want to put an arrow because it says just greater than 4. There's no upper limit. Discontinuous, continuous, that is continuous because you can draw that without picking up your pen. Domain, furthest left appears to be -10. Furthest to the right, because of the arrow, is infinity. Range, the furthest down this goes looks like -infinity because of this arrow going down. The furthest, the height, the highest the y value gets appears to be 5. All right, now the last one. Just two functions, okay? Absolute value of x minus 3. All right, now a parent function looks like this, starts at 0, 0. Know your transformations. X minus 3 is going to be a right 3, so we're going to move this right 3. That just means 1, 2, 3. The vertex is now going to be here. But we only want that from x is less than 4, so it should look like this. Has a slope of 1, up 1, left 1, up 1, left 1, and up 1, right 1. But I want to stop it right when x is 4 and have an open circle. Next one is a line, y-intercept of 2, up 2. So I'm just going to put a little dot there. I know I'm not going to draw the line there, but it'll help me draw my slope here, -1 over 4. So down 1 over 1, 2, 3, 4 puts me right there. Down 1 over 1, 2, 3, 4. And I want that anytime x is greater than or equal to 4. So I'm going to fill that in and continue this on. This is another continuous example. Domain goes left and right forever. Doesn't appear to be any gaps here. Range looks like it goes down and up forever without any gaps as well. The last one. Now on the test, you guys will not see a parabola. Okay, you won't see a quadratic, and you won't see a square root function. I forgot to take them off of the review, but I'll walk you through how to do that anyways, because you're going to have to know that eventually, and that's something we covered last year on this test, but we took it off for this year. But the parabola here. So we have three functions. So hopefully you can see we have a parabola, we have a line, and we have a square root function. That's why we have 1, 2, 3 spots. So let's start with this leftmost one. So we have a parabola. So a parabola, parent function is x squared, and it starts at 0, 0. Very similar to absolute value, right? So what happened? Well, it's clearly upside down. Okay, it's reflection over the x. So we definitely need a negative in front. We know that it moved, so we need a reflection across the x. And we know that it moved left because we have the vertex here. 1, 2, left 3, and up 1, 2, 3, 4, 5, 6, 7, 8. So up 8. That's what happened to this parabola. So how would you write that equation? Well, we have x squared, so we got to modify x squared. So I'm going to first put a negative in front because that's going to give my reflection. The left 3 movement is going to be an x plus 3 on the inside. So x plus 3 squared. And then the up 8 is going to be plus 8. And that is between what two x values? Well, the furthest that this parabola goes on the x is -7, right? 5, 6, 7. So -7 is the furthest left. And it looks like the furthest right this parabola goes is at -1. Okay, the next equation, or the next piece of this, is a line. So that's just y equals mx plus b. Looks like a slope of -1 and a y-intercept of 3. So -x plus 3. That's between an x value of -1 and 2. And I'm not going to include, it doesn't, so this point right here, do you include it with the parabola or do you include it with the line? Doesn't really matter. Technically, it works for both. But I typically tell students just pick one for it to include and not the other, because there is no way to tell where it changes from a parabola to a line. So we're not going to be too picky with that in this case. And the last one is a square root function. So we know square root of x, that's the parent function. Hopefully you know that it starts at 0, 0, and that's what it looks like. That's the parent function. So we know that it moved right 2 and up 1. So this moved right 2 and up 1, this point, okay? Now, how do we get a square root to move, let's say, right 2? Well, in the inside, put a -2. How do we get to move up 1? On the outside, put a +1. And what x value is that? That's starting at x is 2 and anything to the right, so x is greater than or equal to 2. And you don't need to put to infinity if it's written in that notation.